Hi friends, welcome to the Unit 2 Day 7 notes. This is about piecewise functions. Now we're going to be talking about graphs that we have to lift our pencil. So these are called discontinuous functions. So up until now we've been talking about continuous functions. They've been continuous from left to right. Now discontinuous ones are still functions because they only have one specific y value for each x value. So let's go ahead and talk about, for this one here. This example, graphing a discontinuous piecewise function. So this says from -2 to inclusive to 3 non-inclusive. So these are the values. Again, setting up a table is going to help us. So x, and then when we have -2 is less than or equal to x is less than 3. So we're going to just talk about these. So this is our g of x here. So let's do -2. Might want to do, let's see, a couple. -2, -1, 0, 1, 2, and then 3. So yeah, we're going to do a few here with this one. -2 times 2 is -4. -4 minus 2 is -6. Absolute value of that is 6. 6 minus 2 is 4. -1 times 2 is -2. -4, 4. 4 minus 2 is 2. 0 minus 2, -2. 2 minus 2 is 0. 1's 2, 2 minus 2 is 0. Then minus 2 is -2. 2 is 4. 4 minus 2 is 2. And I have 0. 3 times 2 is 6. 4 is 2. So it looks like we're going to have that V shape here, giving me enough to go off. Now this, remember, is open. This is open because at that 3, remember, it's non-inclusive. So -2, 4, 4. -1, 2, 0, 1, -2, 2, 0, 3, 2. Remember, this one's open. So I'm going to connect these using a straight edge. Being very careful to not go past this point right here, because that's as far as the domain takes us. And then again, it's open dot. So I'm going to make sure I don't fill that dot in when I connect it. There we go. Just a little bit short. There we go. All right. So then now plugging into the other one. So this is going to be 3, 4, 5, 6, 7. 5, 6, 7. There we go. Plug in 3. 3, -3. -3 plus 7 is 4. Plug in 4. -4 plus 3. 2, 1, 0. And then it continues on. So 3, 4. 1, 2, 3. 1, 2, 3, 4. So that's here. And then it has a slope of -1. There we go. And then it continues on. So this is a little array we got going on here. So we have absolute value, piecewise, and array. Now, this is a function because here, at this value, it still only exists once. It only cuts through vertical line test. Still only cuts through once. It only cuts through here. My domain we get from looking at our domain here. So it looks like I'm from -2 inclusive to infinity. And our range, it looks like we just have, this is our upper limit. And then here, this arrow shows it's going to continue on. So it's going to continue on forever and then towards negative infinity. But then it's only going to be up to 4 inclusive. Now for this example down here, it's really interesting. I've got essentially, a lot of students get this part confused. This is essentially when you have 3 and only exists at 1. This is a point. This is the point -1, 3, and that's it. -1, 3 is right here. That's that point. A lot of students really confuse that. I wanted to bring that attention. For this other one, basically when x is not -1, remember if it's -1 then we're dividing by 0. So I can have almost any other value that I can use for this. So I'm just going to pick a couple just to kind of get the shape. If you've not seen this before or graphed this before, it's a pretty cool graph. This is called a hyperbola. Let's see. Let's go ahead and put... let's go Yeah, let's go -7. I'll show you what it does. I was gonna pick kind of the extremes here. So if I plug in -7, we're using the top one here. So -7 minus 1 squared divided by -7 plus 1. So -7, that's going to be -8. -8 squared is 64. 64 divided by, looks to be like -6. So this is going to give me some decimal. I always forget to leave my calculator out. I need like a backup calculator that I just use only for recording. Sorry. -64 divided by -6. So it's going to be 10 and 2/3 repeating. Oh, not -64. Positive 64. So -10. And 2/3 repeating. So -10.66666666, and so on. That took me off the graph. Let's try -5. Yeah, -5. So -5 minus 1 quantity squared all over -5 plus 1, -5, -6. So that's 36 over -4. Oh, just off the graph, -9. Try -2. Minus 1 squared. There we go. -2 minus 1 is -3. Squared's 9. Divided by -1. Oh, man. That didn't work out well. So sometimes when you go through, you get these where you're just kind of like, I call this, you're just kind of banging your head against the different values. At this point, I just plug it in and see what it does graphically. So I'm going to show you graphically what this actually looks like. Let's go ahead and plug this in. So I have x minus 1 quantity squared divided by, I'm going to use parentheses for my denominator so it knows that I want it to divide by that entire x plus 1. Let's see what this looks like. So as you can see, down here at the bottom it does this part here. This is actually below our graph, so we wouldn't be able to see this. We're just going to see this part right here. So essentially what's happening, go to our table. See at -1 it says error. At that point this doesn't exist. -2, -9 is actually just down here. This graph does this sort of thing down here. And then up here it goes through, continues on. 0, 1, 1, 0. 1, 2, 3, 1. So here it's this. 4, it's at 1.8, somewhere like that. 2.6, and so on. So it does this sort of thing here. Now again, it's just below this graph down here, so it does actually do this, which is important to know for the domain and range. The domain and range, it actually, normally this is a hole in the graph, like this won't exist at -1. Remember, we can't divide by it, but because we've filled in that hole here, we've got this. So our domain is actually from -infinity to infinity. And then it's maybe difficult to see here, but these values, we don't have anything between. We don't have anything between that -9 value and 0, non-inclusive. So for our range, we're going to go from -infinity to -9 inclusive, union 0 inclusive to infinity. So we're not going to have these values here. Join me in the next video as we determine the equation of a piecewise defined function where we're given this information. Have a great day.